Well, this is 3/2, so we're going to use x plus 3/2 times the quantity x plus 3/2 and get x plus 3/2 quantity squared. And that equals 9 plus 9/4. Again, we always need the same denominator, so if we multiply top and bottom by 4, we're going to get 36/4 plus 9/4, which is 45/4. Okay? From this point on, we're going to use the square root method, and we're going to multiply top and bottom by, or we're going to square root each side. So now I have, let me move this up. Now I have x plus 3/2 equals plus and minus the square root of 45 over the square root of 4, since I'm separating them because this does not work out really nice. Now, you're probably thinking, oh, I have to rationalize the denominator. Well, this works out pretty good for us because we could take the square root of 4, which is 2. So just rewriting everything up here, x plus 3/2 equals plus or minus. Square root of 45 is root 9 times root 5, which is 3 root 5. And then the square root of 4 is just 2. So this works out nice like that. And now I have to solve for x by getting x by itself. So if I subtract 3/2 from each side, I'm going to get x equals negative 3/2 plus and minus 3 root 5 over 2. That's a lot of work. But again, if you wanted to separate your answers, this is what they look like combined. Separate, there'd be x equals negative 3/2 plus 3 root 5 over 2, and x equals negative 3/2 minus 3 root 5 over 2. Okay? So that's what they look like separate in case you see them in the book. Okay. Our final problem of the night is you doing the Pythagorean theorem. I'm sure you've encountered this sometime in junior high, but just really basic stuff in a right triangle. And a right triangle is basically a triangle with a right angle. And we designate that right angle by putting a box, okay? Because this segment is perpendicular to this segment, meaning they form a 90-degree angle. And the other parts of the triangle is that we're going to designate some letters, and A and B are the legs of the triangle, and the hypotenuse is always the longest side of the right triangle, and it's always opposite of the right angle. So the hypotenuse really is always the C value, where the legs can be A or B interchangeably. It doesn't matter which leg is A or which leg is B. Now we're going to use the Pythagorean theorem here, and the Pythagorean theorem, if you recall, is a squared plus b squared equals c squared. And what we're really saying here is that if I take my leg and square it and add it to the other leg and square it, it's going to equal my hypotenuse squared. And the reason we're actually using this is because you may be missing a side of a right triangle. So if you know two sides of a right triangle, you can use the Pythagorean theorem to find the missing third side. So in this case, if you look, it says the hypotenuse has a length of 12. So if I label my hypotenuse as 12 and a leg of length 8, it doesn't matter which leg you label as 8. I'm going to just label my first one as 8. That means I have to find the length of the other leg, or our missing side. So that means I'm missing B in this case. So all I'm going to do is substitute in my values for A, B, and C. Now remember, the hypotenuse always is the largest side, so that is always your C value. So I'm going to say 8 squared plus my other unknown leg here is B equals my hypotenuse squared. So if I evaluate this, I have 64 plus b squared equals 144. And if I solve this algebraically by subtracting 64 from both sides, because I'm trying to isolate our variable, we're going to get b squared equals, let's see, 80. Now I'm going to use the square root method by taking the square root of both sides. Now we have b equals plus and minus. Now if we go ahead and factor tree that 80, you can go ahead and think of a couple ways how to get 80 when multiplied. We could say, okay, well, you could think of right away 16 times 5, which is 4 root 5. So we have plus or minus 4 root 5. If you didn't come up with those factors right away, well then, you could have said, oh, okay, well, 4 times 20. And the square root of 4 is 2, and the square root of 20 is the square root of 4 times 5, and then the square root of 4 is 2, so 2 times 2, root 5 is 4 root 5. So either way, we're going to get plus or minus 4 root 5. However, because we are dealing with a real situation, a triangle, if you think about our separate answers, we're going to have two of them, 4 root 5 and negative 4 root 5. We cannot have a negative length representing as one of the legs of a hypotenuse because length is not negative. So we're going to have to reject any negative value that we get in a real life application. Okay? So we're only accepting the positive 4 root 5 as our answer. And that's it for 8.1 day 2. Thank you.